In today's video, we're going to look at how particles in gases behave, and how they create pressure. If we had a container full of gas particles, the particles would be free to move about in completely random directions. And whenever they hit a wall, they would rebound and carry on in a different direction. Even though they're tiny, the particles still exert a force whenever they collide with the walls of the container. And this means that they create pressure, as pressure is just the force being exerted per unit of area, or the force divided by the area. The total pressure, though, is going to depend mainly on two things: how many of these collisions there are, and how much energy each collision involves. And we can use these principles to understand how the temperature, the concentration, and the volume each affect the pressure. Let's start with temperature. If we were to heat up our gas, we would be transferring energy to the particles' kinetic energy stores. So all of our particles would start to move around faster. And because they're all moving around faster, there'd be more collisions with the walls of the container, and each individual collision would involve more force. As these are the two important factors that determine pressure, we can be sure that pressure increases with temperature. Next up is the concentration. If we increase the number of particles in our container, but we keep the volume the same, then we've effectively increased the concentration, and so there will now be more particles to collide with the walls. This means that there will be more collisions, which again means a higher pressure. Finally, we have volume. If we made our container smaller, but kept the number of particles the same, then there would effectively be more particles per unit of volume, which is actually the same thing as saying there's a higher concentration of particles. As the particles no longer have as far to travel between each collision, there's now going to be more collisions, meaning a higher pressure. So as volume decreases, pressure increases. The last thing I want to mention is that we've so far been considering our containers as a fixed shape. Sometimes though, like in the case of a balloon, the container is flexible, and so it can expand or shrink. In these cases, changes in temperature and concentration will change the volume of the container rather than the pressure. This is because any increase in the number or the force of the collisions would just cause the balloon to expand, rather than increasing its pressure. In reality, it would probably increase the volume and the pressure, as the balloon can only expand so much. You don't have to worry about calculating any of this. You just need to be aware that things are more complicated with expandable containers.